Hey, hey, everybody. Happy Monday. I know, right? You like the Clemson shirt? Well, I mean, we won our first game. And we won some LOL on Friday. Gotta represent. That was some rough. That first game was rough, though, in league. Oh my God. Gotta say, not a huge fan of the project. Yeah, well, it's understandable. The first game ever playing together? Yeah. Kind of seemed like it. I did not stick around. Did they play Rocket League or Valorant next? Or did they just skip to another team pairing entirely? Okay, they got all three in? Awesome. So all y'all that haven't turned in Project 2 yet, y'all got any burning questions? Any desires to know what the hell's going on? How spicy can we make it? The project? I'm not entirely sure what counts as spicy in tic-tac-toe land, but I've already been rickrolled when I've won. So, whatever you guys want to do. Piquant. Yeah, okay. I mean, what are you just going to badmouth Clemson's COVID response or You won, which is way better than what Clemson is doing. As long as you're not cursing at me, I'm not going to take any points off of it. The rumored threat thing, I have no idea. I'm just going to make an Instagram page called Not Trevor Lawrence with a profile picture of Joe Burrow. What? Well, you don't like Trevor Lawrence? He did pretty good. I mean, it was Wake Forest and all, but Oh, well, not in that. Well, I mean, can't hold a grudge for last year. Jeez. I've been holding a grudge since I was 12. I can do what I want. Whatever, whatever. So I guess, ooh, all right. Hey, Tommy, got some reverb going on there, buddy. I'm just gonna mute you, Tommy. Unmute yourself if you want to talk. Yeah, so I'm gonna go over a little bit more HTTP stuff, and unless you guys have any questions about Project 2, or want me to go over any of the stuff I've already gone over about JavaScript, or think I missed anything that's important for Project 2, if none of that happens, I'm gonna go over some more HTTP stuff. I think I covered most of it in the overview, but if I just do that, it's going to be a short day, and I can go back to playing Remnant from the Ashes, which I got for free on Steam, on Epic a while ago, and it's actually a lot of fun. Can't say you have any questions when you haven't even started it. True. Not any good ones anyway. Like, how screwed am I because I haven't started Project 2 yet? I mean, that's a question. I don't really know how to answer it for you, though. Don't really get how to create buttons like the AI button. Roasted. Okay. Well, we made some buttons in the init screen. Let me go over here. No, not that one. That one. Okay. So init screen. In the init, where is my project 2? Okay, so we create this div. We create 3 of these here divs to put buttons into. The reason we make divs is because if we just put them all into the main, okay, so this was supposed to be app, right? I think this was from editing it other week. I'll get to Ashton's question in a second. All right, so we got this, we get the element by ID app, which points us to this thing. And if we just put all of our buttons in here, they'll just be 9 buttons in a row. We won't have 3 by 3 grid. So we put 3 buttons into each div. So we create this div here, and we create a button inside this for loop, and then we add it to the div with append child. And then after those 3 buttons in the center for loop get added to this div, then we add that div to the root node, which is the app thing. So the final, let's see if I can do 34. Let's see if this works. And then project 2 with slash. Nope, I did that wrong. Slash project 2. Okay. So if we inspect this, go back to the browser, we'll see that here's our app div, and after init runs, we have 3 divs inside of it, and each div has a button inside of it. And so if we look back at this code again, that's pretty much what we're doing here. So for the AI button, you want it to also, you don't want to just add it, let's see, you could just add the AI button to the root node, because if you add that button to the root node, it'll be outside of the div. And then I think if you also add the refresh button or replace the AI button with the refresh button, you can pretty much do the same thing. I don't think just create the button and append it to root node, yes. And I don't think, you do still need to get a handle to the AI button at a future point so that you can disable it after it's been clicked the first time. There's 2 ways you can do that. You can give it an ID in this code. You would just do like, you know, AI button dot ID equals AI button. And if you do that, then you can find it again later with the get element by ID call. So that's one way of doing it. Another way of doing it is defining the variable, but not actually doing the create element call up here. So this is what I think makes a little bit more sense to everybody, is let AI button, just define it up here. And then down here, after you've, let's get rid of this. after you've actually created the that whole for loop, you can do AI button equals document dot create element button, and then do some stuff for your callbacks, set the inner HTML to the AI button, all that jazz, and then root node dot append child AI button. And that would work just fine, because then later on, since this isn't defined in this scope, it's actually the variable itself is defined in root scope, you can get to it from your AI on click function, which you'll still have to write. And in your AI on click, you do the same sort of thing, button.disabled, just like we're doing here, to make sure they can't click it again, because that's happened in previous projects. I'm just like, oh, hey, the AI can just go can make all the moves, AI button, AI button, AI button. So you got to disable that. And then you can do the same sort of thing for the reload button, or you can create and add the reload button when the game ends. Either way is fine, whichever way you want to do it. And that question was from Harrison. So Harrison, did that answer your questions? I think so. Okay. Ashton, for the refresh button, can we just reset the button's HTML to dash or whatever the starting character is? Yes, that will work, but there's probably other variables that you're keeping track of. Like some people have the number of plays, which is one way to keep track of like when the game's at a stalemate, you know, like if there's no win conditions, but all the buttons are used up, then your counter's gonna be 9 or whatever. You could also just roll through all the buttons to check to see if they're all disabled. You'll still have to undisable them. So disabled equals false. The easier thing to do is just like, I think it's window.refresh or location.refresh. Checking here. Can't remember how to do it, but let me go back to the browser. And if you just reload the page, it'll reset everything. You don't have to do near as much work. Yeah, location.reload. Yep. What Zach said. Any other questions? No problem. So everybody's totally going to get this turned in on time because they don't have any other questions. As far as AI, should it be random or is there advice I have for a natural algorithm? It can totally be random. I just don't want you to take the chance of like a while random thing. I think I've talked about this before, but I'll just write some pseudocode down here at the end. Like the naive way would just be like while, you know, not found. Set found equal to false, while not found, random x equals whatever, rand y equals whatever, and then if, was it buttons? Yeah, button nodes. If it's not disabled, then found equals true, and then you'll fall out of this thing where you can use rand x and rand y. Don't do this. I will at least take 1, maybe 2 points off for this, depending on how well it's written, or how not poorly it's written might be a better way to put it. Because this, you're just relying on random to eventually find you a good place to put it. Random by itself isn't bad, but let's just copy this real quick. I would suggest instead you do something like this. Right, it's not efficient, and there is an off chance that, like, you know, random is random. It could run for a very long time. It's very likely not to, but you shouldn't rely on likelihood when you're writing your code, you know, like, especially when there's an easier way to do it. Let free buttons equal array. And then here, if button nodes of I of j dot disabled, if it's not disabled, then free buttons dot push this thing. Then close all of these and unindent this so that it doesn't look crazy. Okay, so now we have free buttons that is just an array of all of our stuff, and that's free, and so you make a random number that's between 0 and free buttons dot length, and then pick from that array. Can you make an AI hard mode where they always pick the perfect move? Yes. Yes, you can. I have not done it, but I think there's just a simple decision tree that you can implement that's like, if the board looks like this, then you make this move. Go, you know? Yeah, well, no, I would just read the code to make sure. I could at least hopefully test a cat game and a losing game, and then yeah, if you make a perfect AI, I would just have to read the code to make sure that winning would work both ways, and it wouldn't be too hard for me to do that. So it's not gonna be that terrible for me. But yes, please use something like this. Now remember, free buttons. This is an array, so this is a good point to go back and harp on some things that should already be in your brain. Hard mode AI encrypts the code until you win. Well, I mean, you still have to pull down the code before it encrypts it, otherwise it won't run in the browser. So, I mean, there's no real way for you to hide that code from me as far as I know. At the very least, I can just do a get directly to your code with telnet or something and not ever execute it, which I'm going to talk more about today. I figured out why telnet wasn't working the other day. Time for PHP. You still have to send the code to the client. Oh, you mean have the PHP do all the, yeah, okay. Make the buttons move. What? Oh, just like the click here button that every time you try and click on it, it like moves the button out of my hand. Yeah, okay. That's a different sort of making it impossible. So remember, in this array, button nodes is just an object. So all these things in button nodes, they're JavaScript objects. That's why we can do things like .disabled on them. And since they're objects, they're passed by reference. And since they're passed by reference, when we push it into this new array, we're just pushing a pointer to the button node, right? So it's not copying all the data. Any changes you make to a free buttons of I or of 3 or whatever dot disabled, it's just a pointer to the button node, just like all the stuff in button nodes is pointers to the button. So this stuff will work just fine. You don't have to like do something fancy. Please don't do this where you're like, you know, pushing, instead of pushing the button into the array, push something that's got like an I and a J into it, like an array like this. Like don't, and then you use that array later to find the index, and you're like, oh, well, let me do button nodes of, let me see, this, like free buttons, right, of choice of 0, because that's the 0th entry in that coordinate array that you put in there, and then you have to also do the same thing for that. Like, just don't do that. That's terrible. Please don't. This already gives you pointers. This back here, that gives you the pointer. You can edit that directly. So please don't just like, oh, I'll save the I and the J, and then I'll use that later to find the same button in button nodes. Please don't, because that actually uses up more data than this thing does. And it's just harder to read and harder to write. Yeah. Any other questions? All right. Cool. So let's go back and look at the browser. And so I think we went over most of this stuff already. So I think we already looked at the RFC. This is just a huge pain to read, so I wouldn't really suggest it. Instead, just, wiki HTTP. And this will give you at least, it's still kind of dry, but it'll give you a better idea of what's going on. So it's got the request line, and so you got the first thing. This is the method, right? HTTP method. This isn't a request message. Remember, request and response are different. So it's got the request, and then it's got a single space character. This is important. This may be on the quiz on Wednesday, because I figured, since we're having Dan come in on Wednesday to talk about some networking stuff today, I'm just going to get some HTTP stuff out of the way, since I assumed y'all wouldn't take up all the class time for the project questions, because the people that actually are ahead on things have already turned it in, and the people that aren't ahead on things haven't started it yet. So just kind of assumed that I'd have a decent amount of time free to teach something today, and I don't want to teach the next topic yet, because, well, what's the fun in that, right? So this will kind of be an introduction for Dan's talk that's a little bit more deeply networking, and then the quiz is pretty much just going to be on, I think it's 10 questions about HTTP. That's it. So you have your HTTP method, and then you have a space, and then you have the path that you're requesting. Remember, we don't put in our HTTP packet, at least not on this first line, we don't put, hey, this is the server or the port I'm talking to, because this packet is inside a TCP packet, and the TCP packet specifies what IP it's going to and the port number that it's on and all that stuff. And then another space after here. So if you wanted to have a space in your path, that you can do that, you just have to encode it with the %, URL encoding. I can't remember what the character is, like 4D or something like that, %4D. Just so, because if you actually put a space inside here, it's not going to think of it as part of the path when it gets to the server. Then you have another space. Then you have the HTTP protocol version, which is almost always going to be 1.1. That's the entire first line of your request. Hopefully some of this is sounding familiar. And then remember, you have a bunch of headers afterwards. Headers are separated by new lines, their keys, and their values. So accept language, colon, and colon space is the separator. Each header has its own line, and you can have multiple headers of the same name, and it depends on the web server how it's going to interpret it. Sometimes it'll only take the last one. Sometimes it'll make an array out of all of them. But I wouldn't suggest trying to leverage that, because you really don't know what the server is going to be doing. Okay, so here we got method space request URI. So this isn't just the path. Remember, the URI can also have the question mark with the query string and all that other stuff, like question mark Q equals, kind of like how we have up here. This whole thing from here all the way to the end, including the question mark module item ID equals 1682779. That whole thing would go here in this request URI. Then we have another space. Then we have an HTTP version. Then we have a CRLF, carriage return line feed, /r/n. It's 2 characters. So it is not it's only 2 bytes per new line, right? So you just tack 2 bytes onto the end. The first byte's a carriage return or a /r, and the second byte is a line feed, which is a /n. I think it's r/r/n, right? I think so, yeah. And then after that, you have all of your other stuff. So the primary method for regular browsing is gets and posts. We already talked about this. REST methods use get, post, put, and delete. Generally speaking, options and head generally are used for cores and a couple other things. Trace and connect, really, I never see them at all. Hopefully you guys don't either. I wouldn't say I'd be happy to be working in a job where they're sending a ton of traces and connects around personally. Yeah, it doesn't necessarily have to be a path. So this thing right here, this doesn't have to conform to a path on the page. In our next project, we'll see that in real, like in truth, all right? Because our next project, we're gonna go away from Apache. We're gonna switch over to using Nginx and Node.js together to make our web server. And in Nginx, we just define whatever path we want, and then we define a function to answer that. So Nginx is using JavaScript on the server side. So I hope you're enjoying JavaScript. If you're not, that's pretty much all we'll be doing for the rest of the class. Either JavaScript client side or JavaScript server side. There will be some HTML in project 4, so we'll do some HTML forms and stuff like that. But we're going to be sending those to an Nginx backend, and to a Node.js backend fronted by Nginx. Yeah, okay. But there's probably not a courses 116484. There's probably not that folder on Canvas's website. They're probably doing something where they take that path apart and use parts of it to pass into an overall function that says, okay, I need to look up this thing in the database and that thing in the database and that thing in the database, put it all together. This actually looks kind of like a RESTful URL, by the way, because you're looking at a collection of courses, and then you're specifying the course, and then you're looking at a collection of pages, and then you're specifying the page. It's not quite RESTful, but then again, RESTful is never a protocol. It's just kind of like an idea of how to write stuff. So, it's not that big. I mean, there's so many different ways to write REST stuff. It's more like what did they say in Pirates of the Caribbean? It's not rules. It's more like suggestions or something like that. I can't remember. Yeah, so arg. I got a jar of dirt. More like guidelines. Yes, thank you. Yes, REST is more like guidelines. Since the URI starts off representing the file path, URI encodings try to take that into account. So back in the day, it represented file paths because they weren't running code on their server. They were just like, okay, well, you asked for this file, let me return that file to you. Everything was kind of static files way back in the day. And then PHP came around, and then apparently the guy that developed PHP just kept writing a crappy language because he assumed at some point in the next 6 months somebody would write something better. For like 10 or 15 years, he even admitted that recently. He's like, I don't know, there was a lot of stuff we could have done to clean up the language, but I just always assumed in 6 months somebody would have a much better server programming language for than PHP, so I just didn't care that much. Yeah, there's a YouTube video out there for a 25-year PHP thing where he spent like an hour or 2 hours, hour and a half, 2 hours, and talking about new PHP 7 and 7.2, but also went over a lot of the history of PHP and how he got to where he was and why things are organized this way versus that way. It was a really cool YouTube video to watch. REST UIs also contain variables, so that's like this module item name equals ID, but also if you write your server code well enough, this ends up also being a variable, right? So the fact that it's course 116428, something in their code, there isn't a folder for that, something in their code is actually pulling that out as a variable and saying, all right, I need to look up this in the database. So, but what I'm talking about here is get parameters, and you can also send post parameters, but we'll talk about that later. So let's see if I can actually get Telnet to work today. Where is my console? All right, so Telnet, and I'm on my server already, and I'm just going to do localhost, which is 127.0.0.1. It's the same thing as just doing localhost because I want it to talk to itself. and I want it to go to port 80. And now we're in a telnet prompt, and I can write get /http/1.1, enter, and when I hit enter, telnet is smart enough to know that's a /r/n. And I can do host, because this is what was not working earlier today, or last time I tried this, and then connection. So Apache actually wanted a host. That's why this didn't work earlier. But that's the entire packet I sent. I had two inlines, or two new lines at the end, so I hit enter here at the end of close, and then hit enter again to send a blank line. And it was like, okay, that means the packet's done, and it sent this text response. So this is a telnet connection. This is just an open TCP connection between this, I guess between this server and itself. But it just opens a TCP connection, and you can send whatever data you want over that TCP connection because it's just TCP. It just so happens that the data we want to send is actually ASCII, right, or UTF-8, or whatever you want to call it. It's just readable text. That's the beauty of HTTP. You just send readable text over an TCP pipe. Which is also nice because we can see the response. So we see that it's an HTTP 1.1, it verified the version, and then it gave us a response code of 200 and a response message of OK. It also gave us some headers. So we sent two headers. We sent a host header and a connection close. We can also send connection like keep alive. We can send cookies this way. We can send accept encoding, accept language, all kinds of stuff like that. And then it sends us back, hey, here's the date that this packet was created and sent back to you. By the way, this is sent from a server running Apache 2.4.29 on an Ubuntu operating system. It was last modified. At this point, last modified is used by browsers. So is etag. Both of these are used by browsers for caching purposes. Accept ranges is bytes. Content length is 266. So this all of the content from here on should be 266 bytes. Vary, accept encoding, connection close, and content type. So it even tells us the content type of this file. It knows that it's HTML, so it happily tells us that. And then we see a new line here, or two new lines. I think one of these was actually from me hitting enter up here, because I hit enter a second time. And when I hit enter a second time, before it even started rendering it, it had already like recorded answers back. Because if you just have one new line here, that is not enough for the server to start coming back. Let me see if I can do that again. Get /http/1.1 host localhost connection close, and I hit enter once. I hit enter again, and see, it didn't put that second new line here. It actually put it down here for some reason. That's just because telnet is weird. So this, if I had just one new line here and then I started typing again, that would be a space between the header and the body. And I don't know, I guess that would work. Anyway, you have to have an empty line, just one empty line, and then you can start typing out the body. And so things like sending photos to Instagram or whatever, we already talked about that. That would all be in the body. Normally you don't send a body with the GET request, but that doesn't mean it's like, it's kind of wrong, but browsers and web servers still work just fine with it. Most of them are even really okay with it, and some languages even expect it. And then we see down here that the content that we actually got back was, here's our HTML. Here's what is in that file on the server. And so now, if I go to get/project2/ and I'm not putting index.html, but the server knows to look for that. .1 host local. All right, so here's our project 2. Notice that it doesn't actually give us the index.js file. So as a browser, I would then have to make another request for get/project2/index.html. You can see that in your connection browser. Like if I go look at my project 2 I pull up my inspector and I go to network and I hit reload. You can see that it actually makes 3 requests. Terminal is blocking. Yeah. So it makes this first request, and if we go look at the response, close the preview and show the actual payload, hey, look, it's the exact thing that we got in our terminal. And works the exact same way. And if we go look at the headers, it sends pretty much the same thing. It sends some extra stuff. So if I go to raw, this is the exact raw packet that it sent, right? So get /project2/ says what the host is. The host is just this IP address because I didn't type in a DNS name for it, so that's all fine. It says what user agent it's running. That'll normally be slightly different per browser. It says what it's accepting, so it'll accept like HTML or images or any of that stuff. What language it's running on, so it's like, hey, I'm running US English, not UK English or Spanish or anything like that. It's not a C++ language. This is actually like, hey, I'm running, like my user speaks US English, so if you could actually give me, you know, an answer that's in US English, that'd be great. It also accepts gzip and deflate, so your server can say, all right, well, I'm about to send you this data. It's like a huge 2 megabyte .js file, but over the network, before it sends it over the network, it can actually gzip it down and then let the browser re-inflate it on its side. And connection keep alive, that's fine. That just means that the browser and the server can keep reusing the same underlying TCP connection and sending multiple HTTP packets to it. I think that's what that means. Don't quote me on that. Google it if you really want to know what that means. Upgrade insecure requests. Yeah, it makes sense. Like, hey, if this is asking for something that's insecure, it's fine. You want to upgrade me to HTTPS, that's fine. Pragma no cache and cache control no cache. So we're saying don't cache anything here. And the reason we're saying don't cache anything here, where is, can't remember how to do that in, disable cache. So I talked about this on Slack the other day. In your network tab, there's a disable cache button. It normally, and this works in Chrome and in Firefox. It only normally works when you have the inspector open. So even if you have disable cache checked and you don't have the inspector open, it's still caching. If you don't have this checked and you're making changes to files on your web server, you might not see those changes in your browser. And you might kind of pull your hair out and wonder why the hell is nothing working. I can't make, like, I put, you know, an alert at the very top of the page that's supposed to pop up just so that I can prove that I'm even editing the right file and it's not showing up. That's because your browser's actually cached an older version of it and it hasn't asked the web server for a new version yet. Yep, did that on this project. Yep. So disable cache and keeping this window open. I mean, not just for the disable cache, because you should also be paying attention to, like, hey, okay, well, this one's not an error, but hey, like, here's what's going on. Hey, here's a syntax error. So if you haven't looked in your console and you send me a question that's like, hey, my page isn't open, it isn't loading, it's just a blank page, and I open it up on my end, and the first thing in the console is syntax error, there's a bracket here that shouldn't be here, or even if the syntax error doesn't make sense, but it gives you a line number, like there's a syntax error about a bracket, I'm not even using a bracket on that line, or it's about a semicolon, I don't, you know, why does that even make sense? Semicolons don't really matter in JavaScript anyway, why am I getting this error? Well, go look at the line number. It says index.js, line 28, character 11. That's actually where this init console log came from. All of your errors will probably have a line number somewhere in them that you can start digging through and figuring out what is busted. Okay, so those are all the headers. Cookie is just another header. We aren't using any cookies here, but a cookie is a header. It's not the other way around. A header is not a cookie is a header. Just in case you were wondering, a cookie is food. Yeah, I guess. I mean, it's dessert, right? I guess it's food. Technically correct. Dessert is still food. Yeah, all right. And then we can also look at, here's the response. So we get an HTTP 200 OK. And notice we get a little bit more of a response than we got, if I can switch back to this. we get a little bit more response than we got from got back from the server, I think because we sent more stuff. So what did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the browser, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12. I don't know, off by 1 error. Some of the things we got are like I think we got, encoding gzip. So that's actually that because we didn't ask for any encodings in our version of it, but the browser was smart enough to ask for a gzip. Yeah, so it's got a couple more things in there because the request had a couple more things in there. And then it doesn't actually show the body here because the body is over here in the response payload. So it just pulls that out, but this is all still part of the same request. And then you can see over here that after it got this and it said, oh, hey, there's a script tag that's index.js that I need to go pull that file down, right? And so it makes another network connection. And if we go look at the headers, these headers are going to look pretty much the same. This one's actually accepting star.star because normally when it does the first request, it's either looking for an image or an HTML tag or something. When a file's referenced from an HTML file, the accept is actually a little bit more. So this is the accept for the initial request. It's looking for something that it can actually render. In the script tag, it's like, well, this was included. I don't know what dude's going to do with it. Like, you could request a CVS or CSV file. You could request like some JSON data. You could request just like a binary blob with no extension. I don't know, right? So I'll accept on this request any sort of file, any sort of encoding or file type or whatever. And then most of it's the same. It does even add a refer. It says, hey, I'm loading this page because this other page in project 2 / actually told me to come over here and get this from you. All right, cool. And then it also tried to load the fave icon. And so if we look at this request, it tried to just do get /fave icon.ico and same sort of headers and body and all that stuff. That's why over here I don't have an icon. Okay, wait, all right, browser, there we go. That's why over here on this tab, I don't have an icon. But like up here, I got a nice little red circle. And over here, I have a little Wikipedia W. And on my tab, I don't have any icon. I don't have an icon because this file doesn't exist on my server. And you can see up here that it even like the server responded, right? The server was like, sure, I can answer that request, but I'm going to give you a 404 not found. Like I don't have a /fave icon.ico anywhere on my server. You can fix this. Let's see if I can get a tiger paw fave ICO. Actually, let's just go to www.clemson.edu. And if we go here and refresh, wow, that's a lot of stuff. Okay. ICO. Let's go over here and let's just put /fave, what is it? Without any ICO, n.ico. And we get this tiny little image because why send a ton of, like a huge ton of data for something that's just going to be displayed? But I can save this to my downloads folder. It already exists. Yes, I want to replace it. And then I can go over to my terminal and do, let's see, scp /win home. Well, sure, there's a good generator if you want. I'm just proving a point. I mean, you can use whichever one you want, but you know, being a teacher at Clemson, I feel slightly beholden to try and steal Clemson stuff and put it on my webpage. What's my IP address again? My -i. What is it? AWS personal? Is that right? Yeah, let's try that. And Ubuntu at 34.227.65.70 colon tilde. Let's just put it here on the root. Please tell me I typed all that right. I did. Awesome. I go over here and I do sudo cp tilde/fave and then put that in var www.html. So now we see we got a fave icon. And it's at our root because that's what the browser was looking for. The browser is looking for /fave icon. Now if I refresh, boom, boom. Now I have a little tiger paw up there, and I have no errors in my console, and everything's happy. Yay. Okay. So if cookies, set cookies, we're going to talk about that for project 3. Just know that cookies are headers. User agent, we talked a little bit about that already. It just tells you like what browser, what operating system you're running for. Exported for, we'll talk about that for project 3 a little bit. Authorization will be project 4. I'm sorry, cookies will also be project 4, not 3. So we'll get to cookies and authorization on project 4. Host, we already talked a little bit about. Apache here doesn't really care what the host is because we only have one virtual host. That one virtual host was like *:80. I don't care who's trying to talk to me. I'm always going to serve up this document root. And if you look at Facebook, you know, Facebook has what, like 1 million servers, and they're all answering to facebook.com or messenger.facebook.com or something like that. Like they have multiple servers that are answering just one host name. But you can go the other way. Like if you go to, and this is going to be horribly out of date, but let me see if I can find it. people.clemson.edu. So it doesn't matter. Oh, God. All right. Yep. So all the people.clemson.edu stuff, that's all run on one web server. So we have a DNS entry that says star.people.clemson.edu. Send it this IP address. Don't care. And then that IP address is where all the TCP connections go to, and they all just have a different host header. It's like, hey, I'm looking for craigb.people.edu, or I'm looking for Cyclist or ABC or somebody else that's created something. And then there's one Apache web server that has a ton of folders in it and a ton of configs and says, all right, you came in on this host name. I need to open up this document root, and I need to serve these files from that document root. So there are certain situations where the host header actually completely changes how the server is going to operate, just based on, because, yeah, so there's that. You might want to remember that host header is important. What happened to my, I used it for people at Clemson. Okay. It may include a port. It might just be an IP address. It might be a DNS name before it got converted into an IP address. Yes, it can include a port, so you can, like, your host name might be localhost:3000, or it might be like craigb.clemson.edu, or it might just be an IP address, or it might be an IP address :3000. Like, you can put either of those in there. Except encoding language, yeah, we talked about that. Request body, we talked about all that. There's a form encoding that, yeah. So we'll talk more about the request body later. I don't think that's on the quiz on Wednesday. So I got through all that. So if anybody has any questions, ask them now. If I, tickled anybody's brain about some more questions on project 2 while I was talking about all this stuff, bring it on. Otherwise, if you don't want to listen, explain what a header is again. Okay, a header is just a key value pair. It's anything after, nope, not that one. This one. And this one. So anything after this first line, any line that's and then there's a whole empty line. And if you have an empty line, then the stuff after that. So the actual packet would look like, okay, that's not the right button. So let's say, actually, let's just do it here. Refresh, go look at this thing and look at the raw headers. Okay, so these things right here, everything after the first line is a header. Yep, terminal's still there. Yep. I'm just going to copy this and go to the Sublime real quick. So Copy. Okay, don't want it to copy. All right. Let's see if that actually copied. Quiz today is after class on Wednesday. Oh, it did copy. Okay, so let's go back to Sublime. Switch this to text. And so all of this stuff right here, those are all headers. This is the request line, the top line, whatever the, I forget what we called it. Request line. Yep, all right, got it right. Each of these is headers. So a header has a key, which is all this stuff to the left of the colon, and then a colon and a space, and then all the stuff to the right is the value. Just key value pairs. You can also have data down here. This data could be like a JSON object where you have something like data down here. You know, you could write a whole bunch of JSON here. You could write formed URL encoding, which would be like data equals down here and data2 equals over there. This would all this stuff is data. You could also just have an image down here where you're just like blah, 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 because I'm binary encoding, blah. Like all this stuff is data. That's all part of the request body. Anything that is above this blank line right here in a packet and after this first line here, all of these are headers. You're welcome. Anybody have any more questions? If not, I'm not teaching anymore today. So enjoy the rest of your day. You got a little bit off a little bit early today. Yes, everything after the blank line is the body. And a request can have a body and a response can have a body. Yes, host is also a header. Cookies would also be a header. Y'all too. Have a great day. If anybody has any more remaining questions, burning questions, just hit me up on Slack. I'll be around all evening.